Hi class. In the previous video we took a look at how horizontal heat imbalances become established. Again, and that's in the tropics. You have high solar noon sun angles, tremendous solar intensities, so the incoming solar radiation is greater than outgoing terrestrial radiation, so you build up a surplus of heat energy in the tropics. At the poles, it's just the opposite story. They have low solar noon sun angles or no solar noon sun angles during part of the year. Low solar intensities or no solar intensities for part of the year. And as a result, incoming solar radiation is less than outgoing terrestrial radiation, and therefore they build up a deficit of heat energy in the polar locations. So we've got a lack of equilibrium here in terms of heat energy. And so the Earth atmosphere system will try to move that surplus heat energy from the tropics towards the poles. Okay, we also mentioned that somewhere along this latitudinal line, incoming solar radiation has to equal outgoing terrestrial radiation. That was around 32 degrees north and south latitude. Okay, so now let's take a look at how we move that surplus heat energy from the tropics to the poles. Okay, and this occurs both in the horizontal and in the vertical. And so I'm going to be messing things up here a little bit for you. I have to take this over here and draw it like this. So we have in the vertical, so we talked about this before, we have the movement of sensible heat. Sensible heat in the vertical, sensible heat is moved in the vertical through conduction and convection. Okay, so sensible heat in the vertical is moved through conduction and convection up into the atmosphere, and then once in the atmosphere, then the sensible heat is going to be moved through something we call air mass exchange. Basically, it's high pressures. High pressures are moving warm air from the tropics to the poles and cold air from the poles to the tropics. And so this is what we call air mass exchange. And air masses are going to exchange hot air for cold air and cold air for hot air. And again, this is done by high pressures. Okay, and high pressures are how sensible heat is moved in the horizontal. Okay, sensible heat is moved in the vertical through conduction and convection. Sensible heat is moved horizontally by air mass exchange by high pressures, okay, moving warm air from the tropics to the poles, cold air from the poles to the tropics. Okay, so that's going to take care of some of this surplus heat energy. We can also use latent heat as a means of transferring a lot of this surplus heat energy from the tropics to the poles. So again, I got to do it like this, sorry. And so in this particular case, we've got evaporation at the Earth's surface and condensation in the atmosphere. So basically clouds and storms. Okay, and this is how latent heat is being moved in the vertical. Okay, so latent heat is moved in the vertical through evaporation at the surface and condensation in the atmosphere. Okay, and then once in the atmosphere, latent heat is going to be moved from the tropics to the poles. Okay, and we do this via storms. So basically low pressures. That low pressure might be a hurricane, could be just an ordinary low pressure. So low pressures are moving latent heat horizontally from the tropics towards the poles. Okay, and So these together, and I've run out of room here, I apologize, but storms and air masses, okay, kind of combined, these are going to transfer about 75% of that surplus heat energy from the tropics to the poles. Okay, and so we're almost done now. There's one more thing we need to take into account, and we mentioned this before. Okay, so that's 75% of the surplus is moved from the tropics to the poles by latent heat, storms, by sensible heat, air mass exchange. What about the other 25%? Well, if you remember earlier in chapter 4, we talked about ocean current circulation. Okay, so ocean currents will also transfer some of this surplus heat energy from the tropics to the poles. Okay, and in fact, this will transfer. We mentioned this before, 25% of the surplus heat energy from the tropics to the poles. Okay. So as we move the surplus heat energy from the tropics to the poles, both in the vertical and in the horizontal, this is what creates weather. Okay. So again, that's one definition of weather, but that's the main reason why we have weather across the world, is the redistribution of heat energy in order to try to reach equilibrium. Okay, so that's it for this figure, and we got one more to go to finish off chapter 4.